You're listening to the Common Descent Podcast.
Hello, Will.
Hello, David.
Hello, everybody out there listening to the podcast. This is the Common Descent Podcast, episode 193. This episode's topic is hopping. Hopping like the mode of locomotion, the way you get around.
Yeah.
This is a weird episode topic because we're going to talk about a bunch of different, not particularly related things that are referred to as hopping or kind of hopping. We're going to talk a bunch about the way the different animals get around.
Yeah, there's a whole bunch of animals that hop, and we all agree they hop, but they all are doing very different things.
So along the way, we're going to talk about some of your absolute favorite hopping animals from around the world, and indeed from the past. There will be some discussion of hopping in the fossil record. Of course, returning listeners know that we're talking about this because it was requested. All of the topics of our episodes come requested from our audience. This subject was requested by Tony, Jamie, Taterboy, Sir Psychopathic Cows, and Lady Fuzzlebutt.
Thanks for the requests.
Thank you, everybody. As a reminder, if you, dear listener listening right now, want to send in a request for an episode topic, check the episode description or our website for the topic request form and send it in there. We will go on to talk about hopping after the break, after the news, after the announcements. First and foremost, we have a Patreon.
We do.
The support we get on Patreon helps us to fund the entire podcast, everything that we do, all of this science-y content that we bring to you. There are a bunch of cool rewards and goodies and bonuses that our patrons can receive from subscribing on Patreon, one of which, at certain levels, is a shout-out here on the podcast. On this episode, we would like to welcome new patrons, Nolan, Linmo, and Dr. Nanjo.
Welcome. Thank you so much for your support.
Welcome and thank you. Also, hop down to the episode description or our website to find a link to our Patreon if you would like to support us. Right now is an excellent time to support us on Patreon because it is Croc Month.
Woo!
It is June. Every year here at the Common Descent Podcast, we celebrate Croc Month in June and Snake Month in July, but more about that later. Throughout the month of June, we will have themed episodes and live streams. We will be doing a special Croc Month live stream on June 17th. Check our website links in the episode description for more information about that. And the Croc Chat channel is open on Discord, and the Crocs and Snakes tier is once again available on Patreon. Subscribers at this tier get some special limited offers, Croc and Snake Month stickers, and also the support we receive at this tier during June and July will contribute to charitable donations we will be making later in the summer to reptile conservation. This year, we are donating once again to Crocodile Research Coalition and Save the Snakes, and we're throwing a third one in there, Turtle Survival Alliance, to get some other reptiles in on the mix. It's an excellent time to join us on Patreon because you can support us while at the same time supporting reptile conservation, and even better than that, one of our very generous listeners has offered to match donations this year up to $1,000 on behalf of Mayflower Enterprises, a small engineering firm in northern Indiana, here to help you discover your potential. Whether you're a newly founded startup, have been in business for 20 years, or just have an idea on a bar napkin, Mayflower stands ready to bring their Fortune 100 experience from automotive, aerospace, manufacturing, and construction to help your organization discover its potential through process development, personnel training, future-proofing, and more. Mayflower Enterprises has a passion for the environment, scientific discovery, and deeply nerdy hobbies that include listening to the incredible team at the Common Descent Podcast. That's what it says in the copy. I didn't write that.
They wrote that, not us.
That's their words. We, they say, are so thrilled to partner with them this year to help support Croc and Snake Month by matching funds for the specialty tiers on Patreon up to the first $1,000. Amazing.
So cool.
So cool. Thank you so much to our contributors, to all of our patrons, and to you, everybody out there, in advance for supporting us during Croc and Snake Month.
Yeah.
Also, there's other stuff happening. Our Spotlight series has been going on all throughout the year, and when this episode comes out, we will have just released the 4th episode of Spotlight, where we sat down for a chat about podcasting and paleontology with I Know Dino.
Yes, it was so much fun.
Sabrina and Garrett, who we've worked with a couple of times, Great discussion that we got to have with them. Check that out, as well as the other episodes of Spotlight. Speaking of Sabrina and Garrett, they were also part of a Dino Day live stream that we did on June 1st, which you can find on our YouTube channel, the archived version of it, and probably eventually like an edited version of that to replace the raw footage. We celebrated Dino Day with Sabrina and Garrett, with Amy and Megan from Weird and Dead, and with Jimmy from Dinosaurs Will Always Be Awesome. It was tons of fun. Thank you to everybody who showed up live for the stream. Check that out.
Yes.
Oh, and I almost forgot, we also have a mailing address, and that's important because we got mail.
We got mail. We got some cool mail. We got a bunch of Deinonychus stuff, like stickers and cards from Elizabeth.
Best dinosaur.
And we got 2 shirts from Toronto Marty. Gave us glow-in-the-dark dinosaur skeleton shirts.
Yeah.
I'm wearing mine right now. It's awesome.
Also, Jimmy from Dinosaurs Will Always Be Awesome sent us a bunch of stuff as part of the live stream, so we got a bunch of stickers. He also attempted to send us dino nuggets, and it did not quite go as planned, but it's the thought that counts.
It's the thought that counts. The neckerchief is on one of my big dinosaurs, so it's like, I'm very happy with all the things.
And finally, it's a very exciting time because June is Croc Month, but June is also Pride Month.
Pride Month!
Happy Pride Month, everybody!
Yeah.
A shout out to all of our friends and colleagues and listeners who are part of the LGBTQIA plus community. Whichever of those letters or beyond applies to you, we hope you have a wonderful Pride Month, a wonderful summer, and a wonderful rest of forever.
Yes.
Thank you so much for being part of the Basque and Coil.
Happy Pride!
And that's the announcements. Always a lot of announcements in the summer. There's a lot of exciting stuff going on, and this is the busiest summer I think we've ever had.
Oh, yeah.
For announcements. Now, news. Every episode between the announcements and our main discussion, we like to cover some bits of news from the world of paleontology and related sciences. Keeps us all up to date and gives us an excuse to read the news. Will news us.
Dinosaur scale cellular structure.
All right.
Yeah, this is a really
Now
cool
say
one.
it 3 more times.
No.
Very quickly.
No, I don't want to.
Sinusoidal dorsosacral sail.
Cellular structure. This is awesome research looking at preserved, like the skin layer structure of a Psittacosaurus specimen, and looking at what the featherless sections of skin are like, and what that might tell us about the evolution from scaled skin to feathered skin. This research is by Zhuxiao Yang et al. In Nature Communications, and the article is by Laura Bisus in Popular Science.
Find that link to that article in the blog post.
So we talked about feathers in a previous episode.
We did. 183 was all about feathers.
Absolutely. And as we discussed, the actual process by which they originated and evolved is a big question in vertebrate evolution. How did we go from scaly skin to feathered skin? Because feathered skin is different than scaly skin. Like the structure and the way the skin develops is different. This research is looking at a Psittacosaurus, which is a small dinosaur, cousins of Triceratops, but without any horns or frills, but has that big beaked face.
Yep, episode 87.
This is a specimen that has preserved skin, not the famous one with the cloaca, I don't think.
Sure, a different.
I'm pretty sure this is a
preserved skin
different
specimen.
one.
Interesting.
The
Yeah,
picture
yeah.
looked different, at least.
All right.
This one
Lousy with incredibly well-preserved Psittacosaurus.
right?
Apparently.
Evidently, Psittacosaurus took very good skin regiment. Like, they took very good care of it. They looked at the specimen with UV light to be able to detect the preserved skin. It's not visible just normally, but once you shine UV, it can show you where the preserved skin is. They said it glowed orange-yellow once it was shown.
Okay, yeah, I've seen images of that the fluorescence is activating certain minerals, and it shows off where different things are.
They then took a closer look using X-rays and infrared light to get a much smaller scale look at the skin, and found that the skin layers are actually still preserved in this specimen.
Cool.
Ridiculous. And in those layers, they have some of the cellular structure, so they can actually get a look at what kind of skin cells they're dealing with. The skin they were looking at is from the non-feathered portion, which by non-feathered they meant not the tail, which has those quill-like structures on Psittacosaurus.
The top of the tail in Psittacosaurus has those big bristly quills,
yeah,
which
like
are
a mohawk.
maybe feathers?
Yeah.
That's in the maybe feathers category.
In this study, they were referring to that as the feathered section for this study, and they were looking at the torso area, so the chest, basically. The non-feathery, just scaly bit. They noted a number of things. It's 3-dimensionally preserved in silica, which is unique. That's not something that's been found for other vertebrate tissue preservation.
Interesting.
The morphology of the outermost layer of the epidermis, the stratum corneum, shows signs that are consistent with that it was originally composed of corneous beta proteins rather than alpha beta proteins, which are what we find in feathered skin typically. It does have those different proteins of just normal scaled skin.
We talked about that in the feathers episode.
Yes.
That the two different types of, quote, keratin.
Mm-hmm.
Alpha keratin and then beta keratin, or more accurately these days, corneous beta proteins.
Yes.
Which is a little less catchy.
Yep. So they found the normal scaly proteins, so to speak, in the scaly skin. They also noted that it was thinner than you typically would find on the torso of other scaly animals. Maybe because this is an upright walking animal and it's not needing as much abrasion protection as like a lizard would.
Okay.
So that's just, it wasn't as thick as you might typically expect for a scaly animal. They were also able to take a look at the melanosomes, which are the pigment holding, containing structures in the cells. These are consistent with coloration in today's crocodilians. Mm-hmm. So the way that these are preserved seems like they were coloring that skin the same way crocs color theirs. This is also something that differs from feathered skin, which is typically pigmentless.
Mm-hmm.
And so
makes sense. It's covered in feathers, and those have pigments.
Yep. You don't need your skin to have a pattern on it because you're gonna cover it up with layers and layers of however colorful of feathers you want. This all seems to show that they had, quote, normal scaly skin.
Sure.
On the non-feathered parts.
What we expect from reptilian skin.
So even though this was an animal that has sections that have feather-like structures, the skin that didn't have feathers showed no feather characteristics.
Gotcha. Mm-hmm.
It was reptilian scaly skin, basically, which suggests then that there might be a partitioning of skins, that only certain areas of skin on animals that develop feathers would have been feathery skin, and that the rest would have maintained or remained normal scaly skin.
Interesting.
So that it could have been a thing that feathers developed in sections, that skin starts to change, but the rest of the skin keeps doing the normal job it's been doing, keeps behaving the normal way it's been behaving.
Yeah. That's really interesting because of its implications for other feathered dinosaurs.
Mm-hmm.
Because that suggests that if that's consistent across dinosaurs, we could potentially find skin without feathers and see if this skin would have had feathers on it when those animals were alive. And it can also help us predict the distribution of feathers if feathers can only grow on parts of the body with that type of skin on them.
Yep. Now, it doesn't, from what I looked at in the paper, it doesn't sound like they analyzed any of the tail section.
Sure.
To see what that skin is like.
That would be the next step, is compare those types of skin.
They expect that it will probably have at least some of feathered skin features, but exactly what and how many of them there are, we don't know yet, or at least it hasn't been looked at in this study.
I'd also be very curious to see the same sort of analysis done on truly feathered dinosaurs. Dinosaurs that have pinnaceous feathers like we see in modern day birds, because the Psittacosaurus quills are in that feather extended family category.
I have the same thought.
It'd be really interesting to see like Ornithomimus or something that has bird-like feathers on it and see if that same pattern holds up.
Yes. I would love to see this looked at in other more feathery dinosaurs. They did know that this partitioning of like sections doing different jobs of in different areas of skin does kind of match up with gene expression in the development of feathers in some birds. That during development, while the feathers are being produced in a young bird, the genes show sectioned activation. And they noted that the switch between scale and feather development in the feet of pigeons is governed by this kind of patterned gene expression. So that there could be a similar pattern going on in the evolution of feathers, that it
showed up in different places at different times.
Exactly.
Interesting.
And that this would be beneficial because it meant that basically evolutionarily they could experiment with feathers without changing their whole skin development. Just a patch starts being a different kind of skin.
Yeah.
The rest of the body is now still having the same protection and abrasion resistance and water retention that it normally has without having to change all the way you develop skin.
Very cool insights into feather evolution.
Yeah.
I'll see a lot more studies like that.
Just get more skin layers preserved in the fossil record. That's all you got to do.
Just find more of those. Apparently find more Psittacosaurus.
Right.
Well, my first news for the episode is about worms. Not worms like we have them today, an extinct group of worms from the early Paleozoic.
Ooh.
This is research published in Papers in Paleontology by Richard Howard et al., and we'll link in the blog post to an article on the website of the Natural History Museum, London, in their science news section by Emma Catton. These worms are a group called Paleoscolecids, which are worm-like marine animals that are known from the early Paleozoic. So one of the long list of, quote, worms that live in the ocean, things that are wormy.
Noodly creature.
These are noodly creatures from the early Paleozoic. They've got a bunch of interesting features. They are notably covered in like armor plates, and they've got these tail hooks. They are thought, it seems, to either be an early branch of arthropods or near arthropods, or possibly related to a group called priapulans, which are also known as penis worms.
Yep.
We still have those today. So somewhere in that realm.
Okay.
This study is describing Paleoscolecid fossils from a quarry in Herefordshire, England, which dates to the late Silurian, around 425 million years ago. These are not new fossils, they are redescribed, and part of the reason they're being redescribed is because they haven't been described since we got a bunch of cool new modern technology.
Nice.
These fossils were originally identified in the genus and species Protoscolex latus, but the authors point out that the genus Protoscolex has become a wastebasket genus, which means that just a bunch of stuff gets thrown in there and it has to be sorted out. They're not actually probably all related. This species is known from a handful of different places. These were carnivorous marine worms, up to 10 centimeters long, so not very big. As I mentioned, they've got these armor plates along the body and a retractable throat covered in rows of sharp teeth. So enjoy that.
Nice.
Xenomorph style.
Yeah.
They can extend the throat and the teeth to bring stuff in. It's fantastic.
I love how often worms function like those wibbly toys that you'd get at like gift shops just kept running through your hand.
Just inside out.
Yep, that they just invert parts of their body when they decide to.
The specimens that they're describing are very well preserved, including those armor plates along the body, as well as three-dimensional preserved gut contents. But Paleoscolecids are typically identified using features of the proboscis on the face or the hooks on the tail, and those are not preserved in these fossils. And indeed, the authors point out, outside of Burgess Shale type exceptional fossil sites, we don't typically get those. It sounds like this skin armor, which they call cuticular microornament, is very commonly found for these animals, but isn't typically used for identification in favor of those head and tail bits. Part of the reason for that is that these little micro armors are very hard to study.
Yeah.
Just the structure of them, the size of them makes them hard to study. So for a long time, they just haven't been looked at, and that means a lot of specimens have been under-examined. This study, for the first time, describes the armor ornamentation on Protoscolex latus using modern imaging techniques, electron microscopy and other techniques to get a 21st century good look at these fossils.
Cool.
What they find is that this species seems to be closely related to a group from the Ordovician that's known from whales, which is the genus Radnerscolex. So here in this paper, they re-identify this, not as Protoscolex latus, because Protoscolex as a genus is a mess. Radnerscolex latus is the new official species and genus for this group, which means they're cleaning up the wastebasket a little bit. Interestingly enough, they point out that this is the uppermost known occurrence of Paleoscolecids, stratigraphically, which means the youngest known members of this group of worms.
Okay.
They are very common in Cambrian and Ordovician sites. They are not common in the Silurian. It's thought that they probably got hit pretty hard by the end Ordovician mass extinction, episode 85, and then kind of struggled along for a while through the Silurian at diminished populations. These specimens, dating at 425 million years ago, suggest that this group made it at least to 425 million years. And this is around the same time as an event called the Lau event in the late Silurian, which was a climate event that is coincident with extinctions and turnovers.
Yeah.
So it's possible that this group of worms did really well for a couple of periods, got hit hard by the first of the big 5 mass extinctions, and then made it until this event, and they might have gone extinct at that time.
Cool. There's a lot of neat updating and revisiting stuff going on with this one. Where, like, we got modern technology being used, cleaning up a wastebasket group. I also thought the aspect of the body parts used to identify don't always preserve in all fossil sites is a important note that, you know, when we name something off of Burgess Shale, that might be putting other fossil sites kind of at a step behind because they probably aren't going to preserve as well.
Yeah, so this hopefully is contributing to the features we can now use to identify these species.
Yes, this is why it's important to study the whole animal that you can, because you might not always get the bit that you typically would want to rely on. You might have to use one of the other parts. Very cool.
Yeah. Also in the article, there was a point where they talked about how this is a very late surviving member. This is the latest group, and they hadn't been common since the Ordovician. And in the article, it refers one of the authors, I think, refers to them as living fossils of the Silurian. That, like, in the late Silurian, they were living fossils for their time, which I don't love because of just the term living fossil. Check out episode 90. But I did think that it was very fun.
Yes. Well, it's a fun thing to remember. That's like, throughout Earth's history, there's been groups that have hung on and would be considered a glimpse into the past, so to speak, if you were the one looking at them at that time.
Yes.
Neat. Well, speaking of a group that gets called that a lot of the time, monotremes.
Oh yeah, they sure do.
Yep. This is a research that was identifying an assemblage of Cretaceous monotremes, a relatively diverse grouping of monotremes at the time. This is research by Timothy Flannery et al. In Alcaringa, Australasian Journal of Paleontology, and the article is by Paul Smaglick in Discover magazine. This paper describes 6 species of monotremes. 3 are newly discovered. These were from a fossil deposit that's around 100 million years old, found in Lightning Ridge in northeastern New South Wales, Australia.
Cool. Monotremes, of course, being the weird mammals that lay eggs and stuff. Today, platypus and echidnas, episode 166.
Indeed. These were found in a opal deposit, opal fields. It sounded like some of the fossils were opalized, which is a thing that happens with fossils from time to time. This is the most diverse monotreme assemblage, like fossil discovery on record. 4 of the specimens are known from just a single specimen, so we don't have a bunch of individuals of all of these. Mm-hmm. So they said that this likely means that the diversity and this area is underrepresented at this point, that it's a high possibility we could find more diversity to this area.
Right.
They also noted that no other mammal lineages are known from the deposit, or were found in this initial surveying.
Okay, so all monotremes so far.
Monotremes. This could be that it's just an absence of smaller taxa due to sampling bias, so we might be missing, like, rodent-sized things.
Sure.
And this also could be affected by the fact that this is an opal deposit, and opal mining has taken place in this area, so things might have gotten disturbed before this.
Sure.
But these monotremes show a not only diverse number of species, but body types and morphologies. These were very different across the 6 species identified. 3 of the species that were already known include genuses like Sturdodon, which is one of the largest monotremes of the time. It's like pig size is what I've seen it described as. Ooh. So this is a big monotreme as far as monotremes go on average. Calicodon, which has the hot cross bun teeth. We talked about that in the episode.
Oh, yeah.
Yep. And Steropodon, which they noted in the abstract being additional material helping to confirm some anatomical features of this group.
Oh, cool. So helping to fill out what we know of the skeleton.
Exactly. Specifically the Mechelian groove is
on the jaws.
Rudimentary or absent in this group. So this helped refine our understanding of Steropodon. The new species are also diverse and some weird. These were in the genuses Darigara, which has dental features similar to platypuses and the overall group, which would make it the earliest known species of platypus, if that is indeed accurate. So this is currently the earliest known one. Parvopalis, which seems like a small steropodontid, so similar to Steropodon, but tiny. This is currently the smallest post-Barremian monotreme, which is a time period from about 125 to 121 million years ago. So smallest one after that, which is notably small compared to the rest of the ones they found, it sounded like. And in the picture, it seemed like it was like squirrelish sized. And then Opalios, splendens. This one's the one that's been getting all the attention because it's being called the echidnapus because it has features seemingly in between echidnas and platypus.
Oh, interesting.
It has a mixture of features that seem to lean both ways. Overall, the anatomy is probably more similar to a platypus, but features in the jaw and snout seem more echidna-like. So its face seems to be a bit more echidna, body seems to be a bit more platypus. So this could end up giving us some information and being a key specimen in understanding the splitting of those two groups.
Yeah, that it could be that this is on the platypus lineage, but convergently evolved echidna-like features. Or it could be that it has retained various features from the ancestors of both of these groups, and echidnas have lost all the, what we would consider, platypus features, and platypus have lost all the echidna features, and this one still has some of both.
Yes. This assemblage also does a bunch of things like showing us that the diversity of monotremes, giving a better understanding of how diverse and successful they were during this time of the Cretaceous. It also is helpful in mapping out the tooth loss in monotremes, because both platypus and echidnas today are toothless. Platypus have them as babies, but they lose them. But fossil monotremes, many of them had teeth, but we can kind of watch them slowly lose teeth, and these specimens have a varying number of teeth.
Yeah.
So it's potentially helpful in mapping out exactly at what point different steps were happening. They noted that this shows us that by 100 million years ago, some monotremes still had 5 molars, but some of them were down to 3. So we can kind of put a stage marker of these lineages were at this point at this time now with these new specimens. This also led them to posit that the full loss of teeth in the platypus lineage may have occurred in the Pleistocene as a result of competition with aquatic rodents that began dispersing in Australia and New Guinea at that time.
Very cool to get a bunch of new insights into the evolutionary history of what is otherwise a relatively little-known group.
Yep.
Monotremes are one of those weird groups where we've got 2 main versions of monotreme in the world today, and they're both utterly bizarre animals. And we don't have a very solid sense of how good a representative echidnas and platypuses are of the entire monotreme lineage going back through time.
Yes.
So this is very cool to get a diversity of these animals.
Yeah, they're cool.
Neat. Well, we've got one last bit of news, and this one is about ants and plants.
Ants and plants.
It's more about the plants than about the ants.
Plants and ants.
But specifically, the coevolutionary strategies between some plants and some ants. This is research in Nature Communications by Jacob Swissa, Fei Wei Li, and Corey Moreau, and we will link to a press release in Eureka Alert via the Boyce Thompson Institute. In episode 175, we talked about plant defenses with our friendly neighborhood paleobotanist, Allie. One of the ways that plants will defend themselves, in addition to the obvious sort of thorns and toxins and stuff, is to recruit help. There are a bunch of plants that have structures that are called nectaries, which are special organs that produce nectar to attract, in the case of what we're looking at in this paper, ants.
Yep.
Because if you can get ants invested in the success of your plant body, then those ants will defend the plant. And there are few things in the world that are better to have on your side in a conflict than ants.
Yeah, if you have ants as an ally, you're pretty assured to win.
I've seen Ant-Man. Let's see how it works. These sort of ant-attracting nectaries are very common in angiosperms, flowering plants. There are, according to the paper, nearly 4,000 angiosperm species known to have these.
That's awesome.
Testament to the close connections between flowering plants and, in this case, ants specifically. But they are also observed in ferns. Ferns, which are not flowering plants, ferns are off doing their own thing. there are quite a number of fern species with nectaries as well, which appears to be evolved convergently with flowering plants.
Did not know that.
In this research, the scientists are investigating the evolution of these features. To do so, they do one of those big data set studies. So they got information on plant nectaries, plant habits and habitats, ant relationships, and then combine it all with a big phylogenetic tree to interpret where do these features fall along the evolutionary history of these groups. What can we tell about how these things have come and changed over time? What they found is, for one thing, it sounds like nectaries are more common in ferns than we thought they were. So they recovered multiple origins of nectaries within ferns, like several different groups of ferns have evolved nectaries independently, and they noted that in flowering plants today, the number of flowering plant species with nectaries is more than the number of fern species with nectaries, but proportionally a similar amount of each group.
Oh.
The percentage of total flowering plants that has nectaries is surprisingly similar to the percentage of total fern species that have nectaries.
That's pretty cool.
So ferns are apparently also really good at this. This is a thing they
Yeah.
have done a bunch. In this study, they also use this data to try to estimate when nectaries might have first evolved in these groups. With the ferns, they come up with an average estimate. This is a plus or minus, but an average estimate of 135 million years ago. Early Cretaceous, give or take a bit. And for angiosperms, they come up with an average estimate of 132 million years ago.
Ha!
Give or take. Which suggests that both of these groups likely evolved nectaries first around the same time.
Yeah.
And this is not only around the time that flowering plants are diversifying in the Cretaceous, but it is also around the time that insect and plant relationships are beginning to become more diverse.
Mm-hmm.
The paper actually noted that we have evidence in the fossil record for when ants start to develop specialized relationships with plants, and it actually is estimated to be a little later than this.
Ha!
So it could be that those estimates are just off a little bit and they're actually closer than we think, or it could be that the earliest nectary structures weren't related to ants.
Yeah, they weren't for them.
And then became an ants and plants thing later on.
Cool.
So it seems that both groups evolved nectaries around the same time, but angiosperm nectaries diversified much more quickly, and ferns lagged behind in their nectary diversity. The authors, to attempt to, hypothesize an explanation for this, they noted that in ferns, the evolution of nectaries seems to correlate repeatedly with shifts in those species' habitats.
Mm-hmm.
Specifically, when these are ferns that start out on the floor, the forest floor, and shift up into the canopy.
Oh, okay.
That when fern groups move from the forest floor up into the forest canopy, we repeatedly see the evolution of these nectary structures.
Interesting.
Which suggests that if that is a prerequisite for ferns to do that, that they needed a canopy to be around.
Mm-hmm.
And the authors propose that the ferns that evolved nectaries might have done so by tapping into established relationships.
Yep.
The flowering plants up in the canopy already had nectaries and had a relationship with ants. So for the ferns, the ants were predisposed to react to nectaries in the proper way. That might have allowed them to evolve. So they may have had to wait until they got into the conditions where there were angiosperms already doing it, and that is what allowed them to then take advantage of this situation and evolve their own nectaries.
Yeah, not making their own relationship with ants, but piggybacking off of ones that were already happening.
Yes, this isn't an original fern idea.
Yeah, yep.
The flowering plants did it, and then ferns went up there and said, hey, it turns out if I make nectar, there's all these ants that are willing to come protect me for some reason.
Yep, they love it.
Yep.
Very cool. It's fun when we get more info into this kind of stuff just because of how extreme the relationship between ants and plants are. Plants making nectar to attract insects is like one of the main jobs flowers do.
Sure. And there are floral nectarines in a lot of angiosperms that attract pollinators.
Yes.
these nectaries are specifically extrafloral nectaries.
Exactly.
They are not in the flower.
Like, these are specific structures, and for many plants that are just for, often, a species of ant.
Yes.
Like, it's extreme. So understanding how it happened, and that it's happened so many times in some groups, that's very cool, and really goes to show what a boon this relationship must be.
Yeah.
Like, this must be a huge evolutionary driver once it's able to happen, or starts to happen, because it's evolved many times and become very specialized many times. That's awesome.
We've talked a lot in the plant episodes of the podcast, including the evolution of flowering plants, which was episode 57, about how plants are incredibly influential on the evolution of species around them. But we also mentioned in episode 149 that ants are incredibly influential on the evolution of species around them, because ants are a dramatic force on the planet.
Ants, the plants of the animal world.
Yes. They're everywhere. Get used to it. Very cool research. That's the news, which means we can bounce from the news over to our main discussion.
They're hopping ants.
Where we're going to talk. Sure. The ants, I'm so sorry to tell you this. Ants will not be mentioned once for the entire rest of the episode. This isn't like a declaration. We've already recorded the rest of the episode. And I know. I am extremely certain we didn't mention ants. But we will talk about a whole bunch of other cool animals that hop and skip and jump and all the other things it's going to be great. We're going to have a whole little discussion about gaits and locomotion, and we'll start by exploring what counts as hopping.
Enjoy.
Hopping is a type of locomotion, a way that animals move, but it is not a very specifically defined type of locomotion, which means we get to start off this discussion, one of my favorite ways to start a discussion, with terminology.
Vocabulary.
Locomotion just describes the way that living things move. Gait, G-A-I-T, describes modes of movement, typically limbed movement.
Yeah.
In locomoting animals. Gaits include things like walking and trotting and galloping, and some of those are grouped under running, and running is also one of those that's a little bit vaguely defined. Galloping is one of the high-speed gaits that you'll see in terrestrial animals. Running and other high-speed gaits like that tend to be distinguished by having an aerial phase.
Yeah.
Which is to say, when you're running, there are parts of the run when you're not touching the ground.
Yes.
This is why you can, take a video of a running dog or a person, and you can pause it at the right time, and they're hovering in the air.
Is that one meme of that dog competition dog running and just looks like it's a hovering carpet?
Yes.
Yeah. It's because when you run, at some point, you're just kind of jumping forward until you land again.
Yes. Hopping is a term that is often used for animals that move by jumping a bunch.
Yeah.
Which is a little bit weird to say after having just explained that running and galloping, high speed thing, also have an aerial phase. Hopping, which is also called saltation.
Yes.
Or saltatory locomotion. Also jumping. There's a lot of words sort of mixed up in here that mean a thing that we can kind of picture. There are a bunch of animals that come to mind when you think of hopping animals.
Yeah, if we say hop, you can picture something hopping.
Yes. Kangaroos, rabbits, grasshoppers. But all of those three examples I just mentioned are moving in very different ways.
Yeah.
Those are not the same thing. So hopping is kind of a general, vaguely defined concept. Saltation is also, sometimes it just means jumping. Mm-hmm. Saltatory locomotion sometimes means more hopping. But again, we're talking about sort of a thing that you know it when you see it, but we have to really break down the definitions to get at what exactly it is we're talking about.
There's a lot of different ways to do this thing.
I have, in preparation for this episode, done a bunch of research, reading. I read so many papers. There's so much. And I would say that what we would consider hopping tends to be locomotion that has the following characteristics. A long aerial phase,
Okay.
So an extended period during locomotion that you are off the ground.
So skipping doesn't count.
But skipping also is a little.
Yeah.
Well, we'll talk about skipping maybe. Hopping is often bouncy,
Yeah.
whereas running or galloping tends to be relatively stable. Like if I run, my head isn't really changing level very often.
Yes. Yeah, running's not an up and down kind of motion. It's
Right.
mostly just forward.
Hopping tends to be a bit more up and down sort of motion. Hopping also, I think, generally refers to locomotion where the limbs are used synchronously.
Yeah.
If I tell you to run across a field, you're going to go left, right, left, right, left, right.
Yes.
But if I told you to hop across a field, most likely what you're going to do is hop on both legs at the same time.
Yeah, when you run and you have that aerial phase, you're just pushing off of one foot, or if like galloping still, they're not pushing off all four at once.
Yes.
There's a point where all four are up in the air, but it's not because they're in sync, it's because they're moving in their own ways.
Each foot is doing its own thing.
Yeah.
Hopping, the kinds of things we tend to think of as hopping, tend to use paired limbs in tandem.
Yeah.
So with all of those things in mind, being aware of the fact that hopping is sort of a very general term, I have compiled a semi-arbitrary list of 4 different types of locomotion that I think are reasonable to discuss in an episode called Hopping. Number 1, jumping over and over again. So
I love how technical the terms are.
this is we're professional operation here. Let's describe what jumping is.
Yes.
Because jumping and hopping, again, it's the same thing, but it's not the same thing.
Yeah, if I jump up and down once, a lot of people wouldn't say that I hopped or was hopping.
Sure.
I jumped.
So jumping is just the act of pushing the body into the air.
Mm-hmm.
Basically, all animals can jump. Most animals have some ability to jump to launch themselves off the ground. Usually, this is done with legs. We can jump with legs, but it doesn't have to be done with legs. There are a bunch of insects that have they move their abdomen or thorax in a particular way.
They've got a special like jumping mechanism.
Yeah. Sometimes there is a special, like springtails that have a special appendage that helps them to jump. But also snakes can jump. Legless lizards can jump. In snakes, sometimes it's a little bit like just a big strike.
Yeah. Yep.
They just lunge the head in front of the body forward and the rest of the body follows. Swimming animals can jump, right? Fish can jump. So jumping generally is a very common behavior and ability of animals, particularly terrestrial animals. Jumping is very useful for a lot of things. And this is an important foundation to lay down. The ability to suddenly spring off into the air is very handy. Perhaps the most useful function of jumping is to get away from something.
Yeah, to dodge.
A lot of animal jumps we see are an escape maneuver, to escape from a predator or some kind of threat. Jumping can also be really good for overcoming an obstacle that you can't just walk or run over. Jumping is often used alongside other behaviors like climbing and flight. Most flying animals, most of the time, they jump and then fly.
Yeah.
The flying starts with the limbs.
Yeah, your first step of getting into the air is just to jump.
Yes. Same thing with climbers. A lot of climbing animals will jump to get onto the tree or whatever it is.
Or to jump between branches and stuff.
Yes. So jumping is not a particularly special thing. Most animals can jump. Some animals are specialists.
Jump good.
They jump real good. There are some animals that have physical adaptations that make them exceptionally good at jumping. Frogs, tons of insects, jumping spiders.
Yeah.
These animals often have highly specialized limbs or whatever mechanism it is they're using that allows them to do big old jumps.
Yes.
Yeah, jumping feet at a time. Just these very long jumps. Again, often as an escape maneuver or to navigate around an environment. Like jumping spiders are able to jump from perch to perch. Frogs, most of the time when a frog jumps, it's jumping into the water.
Yes.
To escape from something that it is trying to get away from. Many jumping specialists will hop simply by just jumping repeatedly.
Yeah.
I've seen this referred to as intermittent jumping. It isn't a gait necessarily like we think of with galloping or something like that. It's the same. It's a jump, land, pause, reset, and then jump again.
Yes.
Frogs generally, when they are jumping over and over again, are doing this. Grasshoppers, as far as I know, are doing that. Momentum isn't being carried over from one jump into the next.
Yes.
It's just jump, pause, jump, pause, jump, pause.
Yeah, they're not bouncing, but they're just doing the same motion over and over again. It makes me think of in Legend of Zelda when you use the roll to move Link forward slightly faster than his run, where you're not rolling like a barrel.
Right.
You're rolling, standing up, rolling, standing up, rolling, stand. This is kind of the same thing, except it's a jump instead of a roll. Jump, land, jump, land, jump, land.
Yes. These are animals that are often specialized for big jumps, but not necessarily specialized for a hopping gait, for hopping. That's an important foundation to lay down because it will help us to distinguish between the next types of hopping. Number 2, bounding. Bounding is a gait.
Yes.
This is if you look up, mammal gaits, bounding is one of the gaits that is often listed. It is very similar to galloping. It is a high-speed gait. Sometimes I've seen it counted as a type of galloping.
Oh, okay. Interesting.
A high-speed gait with an aerial phase,
Yeah.
like gallops. But what makes bounding different from something like galloping is that the limb pairs are synchronized.
Yes.
The push-off of the ground happens with both back legs, and the landing happens on both front feet.
Yeah.
And then the legs come back down and push again, notably carrying that momentum along.
Yeah, you don't come to a full stop. You keep moving.
Yes, and the motion of landing transitions fluidly into the motion of leaping again. That energy is sort of transferred through those elastic parts of the feet and leg. This is very similar to when we think about skipping.
Yes.
So if you are a human being on your 2 feet and you're skipping, you come down on your foot and that same motion smoothly bounces up into the next jump portion.
Yeah.
Bounding is extremely common among animals, especially mammals.
Yeah.
A lot of mammals that can gallop also will bound.
Mm-hmm.
It's like cats can bound, deer can bound, rodents can bound. This is a thing in the repertoire of these animals. But there are a handful of specialized bounders, animals that are especially adapted to use bounding as their primary form of locomotion. The most famous of these by far are rabbits.
Rabbits.
This is what rabbits are doing. They are bounding. Also, chinchillas.
Oh, yeah.
And I believe there are other rodents that are
Yes.
also primarily bounding animals. Rabbits and chinchillas are notable because not only are they excellent at bounding, they almost never don't bound.
Yep.
Most animals, if they bound, they're doing it as a high-speed movement.
Mm-hmm.
Right? A cat will walk at low speeds, and it might trot at medium speeds, and then it'll gallop or bound at high speeds. Rabbits bound at low speeds.
Yes.
For the most part. They're still using that same motion.
Yeah, like if you look up a video of just a rabbit moving around like a living room for like a pet rabbit, they still are going do-doont, 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 do-doont.
Yes.
It kind of makes me think of frogs, where a lot of frogs aren't good at walking.
Mm-hmm.
Like there are frogs who can walk very well,
Sure.
but most don't walk like, we think of a cat walking where it's foot in front of a foot. It's I'm just going to hop over to where I'm going and then shuffle into exact position, but I'm not good at walking.
Rabbits are very much like that. Specialized bounders. Technically, half bounders.
Oh.
So bounding and half bounding are 2 different gaits, and what distinguishes them is that in a half bound, the front legs aren't synchronized.
Oh.
So the front feet don't land at the same time. It's kind of catch one after the other.
This feels like a very technical ruling from the tough judge at a gymnastics
Yes,
thing.
that's absolutely it. You were not quite synchronized with those front limbs.
You get 8 points.
That was a half bound.
Yep.
That was not quite a full bound.
Yep.
But bounding,
Yeah.
generally. Bounding or half bounding animals, these rabbits, chinchillas, specialized bounders, often have a specialized limb structure. They have large back legs, smaller front legs, and the leg bones in the hind limbs tend to be long and narrow. Not unlike what we see in a lot of running animals.
Yep. I've always thought of rabbits as very horse-like.
They are very horse-like. Notably, bounding has been classically considered a mammal thing.
Okay.
This is something that mammals have that specialized anatomy to do. But a 2015 study identified bounding in toads.
Oh.
So, like we said before, frogs and toads hop around, especially terrestrial species. Toads, which tend to be the word we use for frogs that move around on land.
Yep.
Episode 91. Typically, those hops are what we said before. A little jump, a reset, a little jump, a reset. It's not carrying that momentum through necessarily. It is intermittent jumping rather than continuous jumping. That study noted that toads in the family Bufonidae will move in a regular continuous bounding gait without stopping between launches and maintaining their velocity from hop to hop.
Cool. Yeah, I can picture that now that you say it. I
Yeah.
hadn't thought about it, but I can picture ones that just go dun 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 dun.
And they, in the paper, they noted that it was traditionally assumed that all frogs and toads were just jump, 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 and that there weren't toads that were truly carrying their velocity along. But apparently, buffonid toads do that.
Cool.
And the authors noted that this would make it the first identification of bounding outside of mammals. A
Neat.
true bounding gait, which is pretty cool.
And see, now that has me thinking of like other running cycles that I can think of. Like crocs, it's called galloping when crocs run.
And
But-
I think it might technically be galloping.
Yeah, but they are moving their front and back legs more in sync than when like a dog or a horse gallops. Like it's much more of a front back, front back, front back. So now I'm curious about
Yeah.
where is the gradient between galloping and bounding?
And here we're hitting the arbitrary nature of this list.
Yes.
That hopping is in quotation marks. I also noted, I found a 2013 study that identified a bounding gait in dung beetles.
Huh?
They noted that certain dung beetles will synchronize the movement of their limbs
Oh, yeah.
in a way that is much like rabbits and hares. There isn't technically an aerial phase.
Yes.
They're not actually jumping, but they did use the term bounding because they move the front legs together and then the middle legs together, and the hind limbs apparently just drag behind the body as they move. So bounding, maybe kind of also a little bit
Yeah.
exists in beetles.
Well, it's neat that because like there's the true facts about sea stars talks about the fact that their fast way of movement is also with synchronizing the tube feet in this kind of bouncy movement that like multiple groups have found this synchronizing limb movement as a way to move speedily, like not just as a way to move but for fast movement.
Hopping category number 3, stotting,
I don't know what this is.
aka pronking.
I don't know what that is.
Pronking,
Though I feel like I've heard this term.
you've definitely seen it.
Yep.
Pronking, and some of our listeners may recognize the word pronking, is a type of motion that is specifically seen in pecoran ungulates.
Yes. Okay. Yes.
Pronghorn, antelope, deer, others within that group. This is the thing they do when all 4 legs push off the ground, and then the legs just kind of dangle in the air underneath them, and then they land, and they hop on all 4 legs.
They jump the way Bugs Bunny jumps when where he just puts all 4 limbs down and just bounces on them.
Yes. This is a specific... Only these animals do this. They do this 4-legged hopping motion.
It was funny because I did not have the moment of, wait, I do remember this term. I went through and went, what kind of jumps? That's a weird kind of jump, and this is a weird kind of term, I bet.
Yep. It is called stotting, pronking, pronging, or spronking. Because every now and then, in the English language, we come up with a thing, and everybody agrees that deserves a silly name.
Yep. That's fantastic.
Spronking is a very weird behavior. I saw a couple of papers talking about how it's kind of a mysterious, odd behavior, because as far as researchers can tell, it's not actually any better than galloping or bounding in terms of movement
Yeah,
capabilities.
it doesn't seem notably more efficient.
Yeah, and these are all animals that can gallop and bound. So why do you also have this additional thing? There seems to be at least somewhat of a consensus that pronking is, in addition to being a locomotion style, a communication tool.
Mm-hmm. Mm-hmm.
That this is something animals are noted to pronk when they are in groups. And often while they're pronking, they're also making noises or hissing or something. One paper noted they'll also often be urinating or defecating during pronking. It seems like this is a type of motion. The benefit of pronking is that it gets you way up in the air and it's very visible.
And go in the bathroom while you add some propulsion. You shed weight.
Yeah, absolutely. So it seems like it is likely something like a warning communication or an alarm communication, possibly for communicating to others in the herd that, hey, something's going on. Look at my weird bouncy gait. Notice this. Or it could be a startle thing to try to startle predators away. But it does seem to be a communicative form of locomotion, which is pretty cool.
I remember seeing it described in one documentary, and I don't remember which one it was, that the idea that it might be a way to show the predators, look how fit I am, I'm not the one to chase. That it's basically a way to show off.
I can't catch that.
Yeah, it's kind of instead of like squaring up and looking big to the predator to make it look like you're not worth the fight, make it look like you're not worth the chase.
Right.
I just made it 8 feet in the air, go for the one that made it 5 feet in the air.
It also makes me think of armadillos.
Yep.
Who will leap. And it's a startling thing.
Yes.
It's meant to scare away a predator to cause them to leave. I also found a 2019 study that used the term stotting for a completely different type of motion, a spring-like movement in harvestmen.
Oh.
A stotting arachnid. Now, again, it's not the same type of motion, but apparently it is this sort of bouncy motion that these harvestmen will do. And those researchers called it stotting, which is pretty fun.
I can picture the motion you're talking about, and interesting.
And then, number 4, the only category of hopping that I have seen consistently called hopping by researchers, and that is bipedal hopping.
Yeah.
This is hopping that happens with just the hind feet, synchronized hops together. This is also called ricochetal locomotion.
Awesome.
Yeah.
What?
It's super cool.
Ricochet rabbit.
There are a bunch of animals that can hop like this. I can hop like this.
Yep.
Like, I can hop on both my back feet. I'm not particularly good at it. There are some animals that will do this occasionally, like certain rabbits will hop like this occasionally, but it's not a main form of locomotion.
Yeah.
There are a handful of animal groups that are specialized for bipedal hopping as a primary high-speed locomotion. The most famous of these by far are kangaroos.
Yep.
This is how kangaroos move. In fact, the whole macropod lineage, kangaroos, wallabies, rat kangaroos, which are different than kangaroo rats, I believe, is specialized for this hopping around on the back feet. Kangaroos and animals within this group often will be bounding on all fours at low speeds and then bipedal hopping at high speeds.
Yes. Which is so cool.
Bipedal hopping is famous in kangaroos. It has also evolved at least 4 times in rodents.
Okay. I knew of kangaroo rats. I didn't know there were that many.
There are kangaroo rats. Kangaroo rats are within the family Heteromyidae and the genus Dipodomys. Here in North America, we have kangaroo rats.
Yes.
Back in Australia, there are hopping mice, which are the genus Notomys, which are mice. They are in the Muridae family. They are true mice that hop around on back feet.
Oh, maybe that's what the guy was from Rescuers Down Under, and he wasn't a kangaroo rat.
If he was in Australia, then he shouldn't be a kangaroo rat.
Yeah, exactly. Well, because I assumed they were just conflating the two, because it's the other hopping animal.
There are hopping mice in Australia.
I didn't know that.
And they hop like that.
All right. Apologies, Rescuers Down Under, for my harsh criticisms.
Over in Africa, there are spring hares, which are rodents, though they're called hares. They are rodents. They are in the family Pedetidae. These are, look up pictures of spring hares. They're very cool. They've got these long tails with often with black tufts at the tip.
Oh, yeah.
And finally, in both Asia and Africa, the family Dipotidae includes jerboas.
Oh, right.
And jerboas are another very famous group of bipedal hoppers.
I had forgotten about a bunch of these.
Yep.
Cool.
And these are all unrelated families of rodents.
Yeah, I think
has evolved multiple times.
I think I had just assumed in the past that they were similar
that
group.
they're just all kangaroo rats.
Yeah, exactly.
That's kind of, yeah, I absolutely have had that feeling in the past.
That's like A, super cool that it's evolved multiple times.
Yeah.
B, super cool that it's evolved around the world.
All over the world. And just you wait, there's another thing that links them that is very interesting.
So cool.
Bipedal hopping is a highly specialized form of locomotion. It is one of the most anatomically specialized ways of moving on land. Bipedal hoppers often share a suite of anatomical features that they have evolved convergently. They have, of course, very big, long hind limbs and often small forelimbs.
Mm-hmm.
Get those arms out of the way. They also all have long, heavy tails.
Yep.
Which are thought to be helpful with balance and maneuvering. The bones in the feet, again, similar to what we discussed with bounders like rabbits, the bones in the feet of bipedal hoppers are often long. Specifically, the metatarsals and the phalanges, the toe bones, are often elongated, often fused.
Mm-hmm.
Multiple elements will be fused together.
You don't want a floppy foot to be bouncing on.
Yep. Other elements will be reduced. So like toes, there will be a reduced number of bones in the foot. They might have fewer toes, and then the bones they do have left tend to be long and fused together. If this sounds familiar, that is because this is exactly what ungulates do.
Yes.
We see this in horses. We see this in a lot of hoofed running animals. These same features of elongated, simplified, strengthened lower limb bones.
Yes.
In some bipedal hoppers, there are modifications to the ankle bones to help make the joint more stable so that there's less chance of something slipping. In some of them, apparently, they also have modified vertebrae in the neck to help keep the neck and the head stable.
That makes sense.
Specifically, I saw this referenced, I think it was for kangaroo rats, and that paper noted it as an adaptation to avoid whiplash.
That's what I was about to say. Like,
Yep.
most other motions we do are fairly, not that they aren't strenuous. Like, running can be very impact heavy.
Sure.
And it can be very strenuous.
But hopping, I don't know about everybody else out there, hopping is uncomfortable.
Like, that's what gives you whiplash, is moving one direction very quickly and then moving the other direction very quickly.
Yes.
Which is the definition of bouncing.
That's what they're doing. That's hopping.
So, absolutely that makes sense.
Now, most of these groups, generally speaking, don't only hop like this. They tend to have multiple gaits. A lot of them also will bound on all fours, like a lot of members of the kangaroo lineage do. And many of them tend to have close relatives who are bounders.
Yes.
So the most basal members of the kangaroo lineage today, I think Hypsiprimnodon or something like that, I didn't write it down, is a quadrupedal bounder.
Mm-hmm.
A lot of these rodents have close cousins who are quadrupedal bounders, which seems like it may very well be that that's how bipedal hopping gets started.
And I think there's arboreal members of the kangaroo lineage that can hop, but don't hop as often because it's not as useful in the branches.
Yes,
so
absolutely.
They're bounding more often.
Tree kangaroos are much more bounders than hoppers in the classic sense.
Tree kangaroo. I love that the term that exists on our planet.
Now, bounding is extremely widespread across mammals. There are some specialists. Bipedal hopping has shown up these 5 times in modern lineages, highly convergent, which has led to the questions of what are the reasons for this and what are the benefits of this. There are a number of benefits that have been proposed for what makes bipedal hopping so useful. A lot of them are very similar to what we see with bounding or jumping behavior in other animals. It is a rapid form of movement. Not only one rapid movement, but as I saw it noted, rapid acceleration.
Yeah.
If you're hopping, you can get started right away.
Yes.
And you can get up to top speed much quicker. Also, bipedal hopping has been noted to make an animal's gait unpredictable.
Oh, yeah.
So if you're trying to escape from a predator or something, it's harder to pin down where this animal's going to be if they move in this jerky, bouncing gait.
Yeah, it's like
trying to catch a football bouncing
yes.
on the ground.
Yes, it made me think of those like...
An American football for all of our international listeners.
I had a bouncy ball that was called a moon ball, and it was this knobbly, like, asteroid-looking ball, but the whole point is it bounced randomly. Because, yeah, while you're bouncing in the air, the predator knows where you're going to land, but once you land, you could come off at any angle.
Who knows where it's going to go? So
that makes a lot of sense.
So, excellent... in theory, for getting away from things.
Juking and hopefully derailing the chase.
In some cases, hopping is faster than running for certain animals. That's not always the case, but in certain groups, the hoppers are faster than their neighbors who aren't bipedal hopping. In some regions, research has found that the bipedal hopping rodents are preyed upon less frequently than their quadrupedal other animals that live in that same ecosystem.
Yeah.
So there seems to be at least some evidence that bipedal hopping rodents are harder to catch than classic bounding animals.
Cool.
Another famous note about bipedal hopping specific to kangaroos and specific to big kangaroos is that in large kangaroos, hopping is more efficient than running.
Yep.
Big kangaroos are excellent at moving high speeds compared to other similarly sized quadrupedal animals. The one specific metric that I saw referenced a couple different times is that in galloping animals, like if you think of a horse or a wolf or something, the faster they gallop, the more and more oxygen consumption they have, the more they need to fuel that metabolic rate.
Yes.
In big kangaroos, they hit a plateau of that oxygen consumption. That once they reach a certain speed, they can continue to go faster without burning more energy in that way.
Which is crazy.
That for some number of reasons, at the size of a large... This doesn't seem to be consistently the case for little rodents, from what I've seen. But for a big-ish animal, big kangaroos are in like the 50-kilogram range, so a little over 100 pounds. So, human size, at the size of a human.
Yep.
Bipedal hopping in kangaroos is a highly efficient mode of locomotion.
And I've heard tons of things about like the way that they maintain their momentum and everything to keep that efficiency, and that the bouncing of the tail and the tendons, that they just are redirecting most of the energy from when they land and not losing a lot of it.
Yes.
Which is, that seems like that should be cheating on a biological level. That's crazy that you can do that.
Another thing that bipedal hoppers tend to have in common, and some of our listeners who are familiar with the animals that I listed may have already picked up on this, bipedal hopping animals are almost exclusively found in deserts.
Yeah.
Deserts, other dry, open, arid environments. All of those groups that I mentioned are dry environment animals. In fact, in desert parts of Africa, Australia, North America, bipedal hoppers are among the most common animals in those environments. Like kangaroo rat, I've seen it cited that in Western North American desert regions, kangaroo rats are by far the most common mammal that you're likely to run across.
Yeah.
They are extremely common there.
Cool. Let's go there.
This seems to suggest that something about bipedal hopping is really good for animals that live in dry environments. I've seen a number of discussions talking about why this might be. It may be that they're just open spaces where there's not a lot of hiding spots, so you have to be able to bounce and move quickly. These are also places where food and water may be more widely spaced, so having a fast and efficient way of moving across the environment may be beneficial because you have to travel those distances to get between places.
Yep.
There may also be something to be said about moving over sand.
Yeah, I was wondering about that.
I haven't seen that discussed specifically, although it will come up again in a little bit later. But it does make me think of things like sidewinding, which also is kind of hopping. We're not going to talk about sidewinding, but sidewinding is kind of hopping. But it is that sort of bouncing motion that helps to avoid the collapsing of the sand dune as you're traveling along that loose sand.
Yes. Yeah.
So it seems that there is some consistent benefit about hopping across dry environments. Notably, fossils for some of these groups show that these groups didn't start out in dry environments.
Ooh.
So I saw some research that was challenging the idea that hopping evolves for dry environment conditions, because a couple of these different rodent groups, their fossil record indicates that they started out in forests. So those researchers suggested that it may have been that from bounding ancestors, hopping got started as a way to navigate a clustered environment. And then as the environment changed and arid, open, desert-like habitats came in, hopping was a particularly good way to get around those environments.
Interesting.
That it might be something that it isn't necessarily evolving within those environments, but if you have evolved those hopping tendencies in a place that is conducive for the early stages of that evolution, it now makes those animals very well adapted for getting around in open, dry environments.
Interesting. Yeah, because my brain was going the opposite way of thinking that deserts might be conducive, not only because they're open and there's no place to hide, so you need to be fast, but also now you can move in a fast, forward, like a galloping horse can't gallop full pace in a forest because there's stuff in the way. So I was thinking of it from the opposite, but that also makes sense that it bouncing around a clustered area could also be in that unpredictable mentality instead of the straightforward movement.
So there seems to be at least some evidence to suggest that bounding forest dwellers then can give rise to bipedal hopping desert dwellers.
Neat.
Which is pretty cool. Now, before we get off the note of bipedal hopping, there is one other group of animals that are very well known for hopping around on two legs, and that's birds.
Yes.
Birds also do a version of bipedal hopping in the sense that they are literally hopping around on their back legs.
Yep.
It's not the same sort of bounding continuous motion that we see in those mammals that we were just talking about, but they do hop synchronously on those feet. Indeed, apparently, birds across the board while on the ground either walk or hop.
Yeah.
Outside of a handful of exceptions that can do both, while grounded, birds will either walk left, right, or hop on their legs across the ground. And the distinction seems to be that strongly correlated, hopping birds tend to be ones that dwell in trees.
Yes.
And the idea in this case is probably that living in trees has predisposed these birds to be well adapted for hopping around in branches. And that just means that their hip structure and their leg and foot structure isn't good for walking anymore.
Yeah.
So when they're on the ground, hopping is what they're well adapted to do.
Yes, because they land on a branch with both feet, and branches aren't usually close enough together that you can just reliably walk to the next branch with one foot.
Right.
So you have to hop or flutter to the next branch with both feet.
So in the case of bird hopping, it seems that this isn't something that is a specialized form of locomotion. It's a side effect.
Yeah.
You have evolved to hop around in trees, and that means when you're on the ground, you're kind of stuck hopping.
Yes, it's evolved kind of into corner, so to speak, but like you've evolved into a set way of moving.
This is also the case with the one other group of animals that I want to mention that are famous for hopping around on two legs, which is lemurs.
Lemurs!
Look up YouTube videos of lemurs jumping.
Look up Zaboomafoo.
Look up Zaboomafoo. Look up Suffolk lemurs, and you will see these just truly ridiculous videos of them on the ground, arms up in the air, just hopping on their back legs.
And they do this kind of sideways, like
yeah, they do it. They're like a crab hop.
Yeah,
almost.
And it once again, it's because they're good at climbing that way.
Yes.
And now when you put them on the ground, they just kind of have to keep moving. It's like when you put a sloth on the ground. It's like, I can only move one way, so I'm going to just keep doing that. But
yes,
now horizontal.
Lemurs are very well adapted for leaping around in trees. That's what they're good at. They got these long back legs, these short arms. So yeah, on the ground, they don't really have a recourse. They're not good at walking, and they don't want to crawl, but they're great jumpers.
Yeah.
So they just hop. Now, technically, and I didn't see this discussed anywhere, but I did see it on just looking at videos of them. It looks, to my untrained eye, like they are not leaping and landing with both feet at exactly the same time.
Yep.
That the feet are out of sync a little bit, which I think technically makes it skipping.
Yes.
That's because that's what skipping is.
Yep.
Skipping is hopping, but with the legs, the feet hitting and leaving the ground at slightly different times.
Yeah, you're hopping off of one foot, but both feet up in the air, and then landing with another forward, and then hopping off of that front foot.
So maybe that's half hopping, but I have seen that type of movement referred to as skipping in other papers about other animals.
I say we make that canon. Lemurs skip. No further conversation or discussion needed. Lemurs skip.
Skipping, lemurs. Lemurs and their whole sort of group.
Ugh.
So, hopping can refer to a whole bunch of different types of motion. We could just focus in on like bipedal hopping in kangaroos and those other rodents, but then it would feel weird to talk about hopping without talking about rabbits
Or
and frogs.
Yeah.
So there's a bunch of different types of locomotion that fall under this concept of hopping, and they come from all sorts of different backgrounds. Some of them are just sort of extensions of galloping at high speeds. Some of them are just jumping, but
A bunch.
Some of them are animals that hop on two legs because they have to hop on two legs because you have no other recourse because you've been so adapted to do something else. And then there are things like your bipedal hopping mammals, which seem to be highly specialized for this specific type of high-speed locomotion.
It's fascinating how many different groups have found some form of hopping or bounding or leaping to be a main form of getting around. Especially since a bunch of them, it also seems to have limited their other ways of, like, rabbits aren't particularly good at walking, and kangaroos have to kind of bound, and a lot of them use that tail assisted, that 5-limb walking.
Yeah, kangaroos are not good at walking. They can't just do one after the other very easily.
They have to use the tail to help them because they only can really move one way. So that seems like it would be limiting, but evidently it is successful. It's got the thing flying has. You have to give up a bunch, but evidently what you gain is worth it.
Yes.
Which is cool.
You'll also notice that there is an overwhelming trend in the size of animals that can pull this off. Outside of kangaroos, hopping animals are pretty much exclusively tiny creatures.
Yes.
Like rabbits is about as big as these things are getting. The lemurs can get a little bit bigger. Some birds can get kind of big, but those are usually not the hopping ones.
Yep.
Hopping around is the purview of small animals, which makes all the sense in the world.
Yes.
Because once you get to a lot of big animals can't even jump.
No.
Like, your ability to leave the ground becomes significantly less the higher up in the weight class the species gets.
No, it's like, humans, we can be very good jumpers, but to be able to jump higher than we are tall is a ridiculous feat for most people.
Right.
Well, if you're tiny, you can jump 5 times your height because gravity is affecting you differently. Physics has shifted in your favor, so you can launch yourself off and really leap.
I suspect that that's one of the reasons why hopping is so common in insects.
Absolutely.
And with something like grasshoppers and locusts, that, from what I can tell from what I've read, seems to be intermittent jumping for the most part. That it's a jump and then a reset and then a jump and then a reset. But they're so small that the reset can be very, very quick.
Yes. Well, and they've also, they can walk, but they don't use the leaping back limbs to walk. They just fold those back legs up, and when they walk, it's just the front forelimbs.
Yes.
So they've got these, specialized leaping limbs that just stay in reserve, tensed and ready, and then once it's time to leap, they just unleash them, and they go wherever they end up going.
So hopping in its various forms, quite common around the world today, a handful of specialists. One might expect that there would also be evidence of hopping animals in the fossil record. And one would be right.
Hey!
And because this is, at its heart, a paleontology podcast, after the break, we will explore hopping evidence in the past. Stay tuned. as we saw in the first part of the discussion, hopping can mean quite a lot of different things. So in this portion where we talk about hopping evidence in the fossil record, there's going to be a bunch of different things we're going to talk about. So once again, we are going to, if you'll forgive me, bounce around a little bit. The easiest way to identify hopping animals in the fossil record is to find members of modern hopping groups. There are lots of these. We've talked about a bunch of these in episodes past. There are fossil rabbits. There are fossil kangaroo rats. We did news about fossil kangaroo rats not too long ago. Yeah. There has been, in particular, a bunch of research on the fossil history of macropodoids, which is the kangaroo lineage.
Yes, they have a bunch of fossil members.
And because they're so specialized in their anatomy, we can draw conclusions about what they were able to do in the past.
We also had a news about that recently.
And we had a news about that.
All the different kinds of locomotion they were doing.
Fossil kangaroos and their relatives show a variety of different types of locomotion, but the oldest ones back in the Oligocene already have limb proportions and ankle structure and things like that suggest they were hopping. Mm-hmm. That this is something that started way early on in this lineage, possibly a combination of quadrupedal bounding and bipedal hopping, and then later on those larger-bodied endurance hoppers. I've seen them described as endurance hoppers.
Which is so cool.
Are something that evolved later on, possibly multiple times. I think I saw a reference that that's something that may have happened multiple times.
I think the news mentioned that one of the groups that seemed to be convergent.
Mm-hmm. Interestingly enough, in the history of kangaroo evolution, there are also kangaroos that have been interpreted as being secondarily hopless. Kangaroos, members of the macropods that have lost the ability to hop, whose bodies have changed and lost some of those adaptations. These are consistently kangaroos that were too big.
Yep.
Research has estimated that the optimum body mass for endurance hopping, the best mass to get the most efficiency out of that bipedal hopping movement, has been suggested to be around 50 kilograms, around 100 pounds, a little bit more than that, which is roughly average for big kangaroos today. Unsurprisingly, that's sort of where they have centered on. That's the most efficient size to be.
Which is very interesting that it seems that it gets more efficient as you get bigger, but then you lose that ability as you get past that. Yeah.
Part of the reason for that, I read up a little bit about this, is the scaling of the specific tissues and tendons and stuff. Mm-hmm. And once you get big, it just becomes so much harder to move that mass off the ground, and you really lose the efficiency of it. But I saw a lot of discussion that at too small a size, hopping doesn't work anymore. Yeah. Because the tendons can't be the right proportions to store that elastic energy between hops.
If you had enough tendon, it would be too much for your tiny body.
Exactly. Yeah, absolutely. It's too thick a tendon in order for it to work that way, or the proportion is off in some way.
Oh, because I was assuming there just wasn't quite enough momentum to your tiny body. That like air resistance and everything would just be too much.
Sure, and there could be some of that too.
But that also make that just the physics of that you're still working with effectively the same tissues and tissue limitations as bigger mammals. It's like a rubber band. You can make a giant rubber band, but it's not going to behave the same as a tiny rubber band.
Yes.
Same material, same rubber, but it now behaves differently.
So there is a range of size that is good for hopping, and if you're too small or too big, you can, at least bipedal hopping that we see in mammals.
Yes.
You can't do it.
That's the physics that's going on here is so cool.
Yeah. We'll have links in the blog post for those of you who want to dive deeper into the physics of this stuff, because we're not going to get too deep into that this episode. There are two extinct groups of giant kangaroos that have been interpreted as being not bipedal hoppers anymore. Protemnodon, which grew up to an estimated 170 kilograms, almost 400 pounds, and the subfamily Sthenurinae, which are estimated to have grown up to almost 250 kilograms, over 500 pounds. Giant kangaroos. These were huge. Both of these have been noted to have anatomy that seems to have lost some of those specialized hopping adaptations in the limbs and in the spine. Protemnodon has been suggested as a quadrupedal bounder, more similar to other large mammals. And the Sthenurians have been proposed as just walkers.
Yeah.
Bipedal walking. That these seem to be animals that have exceeded the limit of size for being good at hopping.
Yes. And it makes sense to a degree of like, elephants can't gallop, but they don't need to gallop because what are you running from?
Right. You don't need to leap out of the way of something.
Like,
you're an elephant.
have you ever seen the muscles on a kangaroo today? Like, if that turns around to you, but it's just 500 pounds of kangaroo, you don't mess with it.
What are you running from? Just punching megalania.
just grabbing this. Come here.
Modern groups of hoppers are not the only animals in the fossil record that have been interpreted as having adaptations for hopping. There are a handful of extinct mammal groups that have been suggested as possibly hoppers. Argyrolagus is a metatherian, so close to modern marsupials, from Miopliocene South America, which has been noted to have long hind limbs, reduced foot bones, muscular hips, reinforcements in the joints of the limb, similar to what we see in bipedal hoppers today. So it has been suggested as possibly another origin of bipedal hopping. There's also a variety of late Cretaceous mammals that have been noted to have adaptations that might be for somewhere in the range of running to hopping.
Yeah.
And potentially saltatory animals. This includes certain early eutherians, so early relatives of placental mammals, as well as at least 3 different genera of multituberculates, which is an extinct group of rodent-like mammals, which would not be at all surprising given how similar multituberculates are to rodents and the fact that this has shown up several times in rodents.
Oh, that's cool. I wonder if they were also living in similar environments and everything.
I'm so glad you asked that question. Stay tuned. Stay tuned for that. It is difficult to say for certain, just from the anatomy of the skeleton, that these were hopping animals, but at least that they had the potential for hopping.
Well, and like you mentioned with a lot of the modern hopping and leaping, is that many of them can hop or bound or like.
Yes, and now we're in that question, that classic question of, could it and did it?
Yes.
Do some sort of certain behavior.
Like maybe it's one of those where it's like, yes, sometimes it did, but not usually. Or it usually did, but sometimes it didn't.
Or it could, but it didn't.
It just didn't for some reason. Like evidently that alligators should be able to gallop, but they just don't.
Mm-hmm.
And we don't know why. Stuff like that.
If those anatomical interpretations are true, it would suggest that hopping in mammals goes all the way back to the Cretaceous.
Cool.
This is supported by footprints.
No way.
Because hopping is a thing that takes place on the ground, which means that it is a thing that can potentially leave tracks behind.
You said supported, and it took my brain a second, and then my brain got there just a second before, and I was like, no, that's awesome.
Hopping fossil footprints are not common.
Yeah, no.
But they exist.
Oh, that's so cool.
This is going to be one of those Sicilian examples where I might be listing every ichnotaxon of hopping animals right here in this episode.
Cool.
Brasilicnum is an ichnotaxon, so a species, genus essentially, of footprint that is known in Brazil and Western North America. These are footprints from near mammal synapsids, so mammalia forms, not quite mammal, but along the mammal lineage, that date to the late Jurassic to early Cretaceous, some of which do seem to show bounding. Here's what bounding footprints look like. Bounding tracks have the manus tracks are small and close together, and the pes, the foot tracks, are large, spread out a little bit, and in front of the hand tracks. Because if you look at the way that a rabbit bounds, they land on the front feet, and then the back feet come around in front of or onto the side of the hands, and then push off from there.
Yeah, well, it's like if you watch slow motion of a cat or like a cheetah running, and their body just curls up for the back legs to come forward for the next push.
Yes.
I wasn't sure if they would be in front of or beside, but that makes sense.
I think it can be both.
Yeah, it probably depends on like the rate or the specific one doing it.
In some of these cases, the feet are in front of the hands.
That's cool.
Which is very cool. I saw it noted about these footprints that the prints aren't always quite lined up right next to each other, which makes this half bounding, like in rabbits today. Some Brasilicnum footprints have no hand prints.
Oh.
Only feet. 2 feet, then 2 feet, then 2 feet.
Yeah.
Bipedal hopping.
That's cool.
Notably, in the cases I saw described, the hopping back feet are also not perfectly lined up, which makes this skipping.
Prehistoric skipping.
These are mammaliform footprints from North and South America as far back as the late Jurassic that show both bounding and hopping on 2 feet. Technically half bounding and bipedal skipping, but hopping maneuvers in these mammals or near mammal animals.
Absolutely. And it shouldn't be too surprising because it's so many hopping and leaping and bounding things today that surely it's but that's so awesome.
How cool is that?
Oh.
Notably, these tracks come from sand dunes.
Hey-o.
Fossilized sand dunes, which suggests that whatever animals were leaving these also lived in arid environments. One paper that I read noted that in the Botucatu Formation of Brazil, so there's bounding tracks and skipping tracks. There's also running tracks, and I think maybe there were walking tracks. So there were a bunch of different types of locomotion preserved within this one genus.
Cool.
They pointed out that the bounding and skipping tracks are only seen when the trackways are moving uphill.
Oh.
Up the sand dunes, which goes back to that thing we talked about before, that bounding or hopping might be particularly good at moving up loose slopes.
Yeah.
Kind of like sidewinding.
So that the sand doesn't sand slide. You don't get a shifting of the sand underneath you. Interesting. And this is so intriguing because, like, had you asked me whether jumping on sand or running or walking, I kind of would have assumed that impacting sand with a jump might not...
You sink into it.
Yeah, you sink it, or you're going to disturb it more because it's all your weight all at once. But maybe it's like the non-Newtonian fluids where hitting it makes it react differently than pushing on it.
I would also, I think it's probably important to note that these are all small animals.
Yes.
If we tried to jump up a sand dune,
yes,
we might be big enough that that's immediately going to start collapsing the sand, but maybe for smaller animals it works better.
Ooh.
Those are not the only hopping footprints. There are bounding tracks called Amazignycus from the Jurassic of Argentina. There is an ichnotaxon called Coreosaltipes from the Jinju Formation, late Cretaceous of Korea.
Nice name.
This Coreosaltipes is known from several, I think it was 9 different trackways, paired footprints of a mouse-like mammal or near mammal that are only the feet.
Cool.
Bipedal hopping in the late Cretaceous of Korea. Now that one, as far as I could tell, isn't an arid environment.
Okay.
So that might be an exception to that trend.
Yep.
There are also Cenozoic examples. Musaltipes is an ichnotaxon of rodent tracks from the Miocene that have been found in Colorado and Utah. There are 2 species, ichnospecies, within Musaltipes. One is bounding tracks, the other is bipedal hopping tracks.
Neat.
So we've got both. And then I also saw a reference of possible Musaltipes from South Africa that was also bounding tracks. And that one I made a note because they specified what animal it might be. Ooh. And they suggested that it might be a gerbil. Or something similar.
Cute.
Because gerbils are also very hoppy.
Yes.
Little rodents.
Yeah, they feel like on your way to kangaroo or hopping mouse kind of body plan. They've got the long tail.
Yep.
They're very mobile, but they don't quite have those big back legs.
So hopping trackways of mammals are certainly not common. Like I said, I think I've just listed all of them. Or at least all the ones I came across.
Yeah.
And I looked a lot. But we do have them from the Miocene, the Cretaceous, the Jurassic. Mammals and their relatives have been hopping since the age of dinosaurs, which is pretty cool.
Yeah. That basically, for the most time that we've had mammals, there's been some that have been hopping.
Mm-hmm.
That's pretty cool.
Which is pretty cool. Also hopping in the fossil record since the age of dinosaurs, frogs.
Yep.
Ranipes is an ichnogenus of trackways first identified in 2014.
Oh.
This is a very recent discovery of, or at least naming of this ichnotaxon. These are clusters of 4 footprints similar to the bounding prints, but the hands are in front of the feet.
Yep.
Because it's a frog.
Because you're landing.
And actually there was one paper that described an example of just one set. So the first time it was described was from the Eocene of Utah, a trackway that had 3 clusters of these. And they described that they are deep prints because you land on the front feet and then you push off with the back feet.
Yes.
And that makes these deep prints.
All your body weight's going into both sets.
Yes. So there were these 3 clusters in a row, which is 2 hops.
Yeah.
2 hops this time.
Oh, that's so... It's either a frog hopping or someone playing with a frog in the mud.
And a primate just slapping frogs down. There was one other example that I read about of ranapes that was just one cluster. And in the paper, they noted that this was either a hop or just a sit.
Yes, yeah.
The frog just sat here.
Both vary in character.
Later, just in the last several years, more frog tracks have been identified from the Cretaceous of Korea.
Oh.
A 2018 study identified ranapes on Sauk Island. They found 16 trackways with a total of at least 65 tracks.
Wow.
So just frogs hopping all over the place over there. And then a 2019 study found more from the Jinju Formation, which is the same one that had Korea saltipes, the mammal hops, which is the oldest known frog tracks, I believe, at up to 112 million years ago.
Awesome.
Now, at this point, I should note that these are these hops in the way that toads are bounding, or are they but it's frog tracks and they're hopping around.
Yes.
So they are jumping tracks at least.
Yes.
Again, we're keeping it loose with what counts as hopping. So we have frog and mammal hops all the way back to the Cretaceous and Jurassic period. Reptiles are an interesting scenario.
Yeah, they have been notably absent in a lot of our discussion thus far.
In fact, we have hardly talked about them at all.
Yep.
Birds hop.
Mm-hmm.
As we've mentioned, I have seen references in paper to hopping bird tracks that look like synchronized tracks, similar to what we see today. I've seen some references that have described tracks like that all the way back to the Cretaceous.
Makes sense.
Which is not particularly surprising. Outside of birds, hopping in reptiles is extremely uncertain.
Yeah.
It has been suggested for other dinosaurs. There has been discussion about were small dinosaurs hopping, were big dinosaurs hopping, because of course a lot of dinosaurs were bipedal.
Yeah.
And they are shaped, a lot of them, kind of like kangaroos.
Yeah, and there's ones right in that kangaroo size range that have a kangaroo shape with a kangaroo-ish tail, so like, why not couldn't you have?
There doesn't seem to have been any direct evidence for hopping in dinosaurs. Birds hop, but that's a specialized feature.
Yes.
That seems to be an offshoot of arboreal habits. And we have tons of trackways of dinosaurs, and they are always walking and running asynchronous steps, left, right. So there isn't really solid evidence to suggest that there were hopping dinosaurs. Hopping has also been suggested for dinosaur ancestors, that early members of the lineage might have been hoppers, but again, this is proposed, but it's hard to find direct good evidence for that. One reptile in particular that has received a lot of discussion in this regard is Scleromochlus, which is a late Triassic Archosaur something or other. It is within the Archosaur group. I think Scleromochlus over the years has been variously assigned as maybe a dinosaur ancestor, maybe a pterosaur ancestor. Exactly where it fits has been uncertain. Scleromochlus has big long limbs, a long tail. It has been suggested as a variety of different types of motion, as a runner, as a tree dweller, although others have disagreed with some of that. A number of papers have pointed out that it has a similar body shape to hopping mammals today, and have suggested maybe it was a bipedal hopper. A 2020 study suggested that it was a quadrupedal hopper, like frogs.
Okay.
So there's been a lot of discussion about this specific animal in the fossil record, and hopping has come up several times, but this is another thing that has kind of gone back and forth. So anatomical evidence for hopping in reptiles has been elusive outside of birds. There have been some suggested trackways of hopping reptiles, though not all of them have stuck around. Saltosauropus was a trackway identified from the Jurassic of France that was originally suggested to be maybe a hopping dinosaur, but it sounds like it was later reinterpreted to be turtle swimming tracks. Which sounds silly at first glance, but then when you think about it, swimming tracks could absolutely look like hopping.
Yep. Well, I was thinking that earlier when we were like defining bounding. I was thinking of different types of swimming. Like the freestyle is more like a gallop where your limbs are all moving in their own way, while a breaststroke is much more like bounding, where your front limbs, back limbs, front limbs, back limbs, front limbs, back limbs.
And a lot of swimming, we haven't talked about swimming very much, but a lot of like bottom-dwelling animals will do sort of a kick off the bottom and then drift for a little bit and then land again and then drift for a little bit.
Kind of like how hippos skip off the bottom.
Yeah. So Saltosauropus is maybe out. A few footprint taxa have been identified from the Jurassic of Africa that have been described as bird-like footprints that in some cases are paired. And possibly hopping. There are 3 genera of this, and since I've been naming all the genera that I have found, Saltarocarpipes, Melapopentapodiscus, and Maluta tetrapodiscus.
Whew.
Those are a lot of fun. There'll be a quiz at the end of the episode. These
I
are
will fail this quiz.
Bird-like clawed footprints. So in some ways, somewhat similar to what we see in birds today, where these might be gripping feet, or at least feet with traction. These have been identified as possibly some sort of archosaur. Well, the paper that I read that described one of those described them as being perhaps small dinosaurs, or even perhaps basal pterosaurs.
Oh, okay.
But difficult to say for sure, but they do appear to be paired footprints. And this is from the Jurassic period, so earlier than we'd expect to see true birds hopping around. This seems to be the best direct potential evidence for hopping reptiles that we have. At least that I found referenced anywhere. So there's not a lot to go on with reptiles in terms of hopping. One thing that I will note from the paper that I read, these hopping potential reptile archosaur footprints are from an ancient desert.
Hey-o.
So at least that is consistent with our stuff so far.
Neat.
So reptiles might just not hop for one reason or another.
Yeah, is the case today. And if that is so, there's many reasons why that could be physical limitation. I wouldn't be surprised if there's like a metabolic thing. Like,
sure,
there's lots of behaviors that mammals do that are good for high octane metabolism that mammals have and don't really work for a lot of other groups. And I wouldn't be surprised if hopping could fall into that category of it's just too energetically expensive for something that's not using a mammal-like metabolism.
Yeah. Although with dinosaurs you'd expect,
yes,
because they are so mammal-like in so many ways,
exactly,
anatomically. A couple reasons, and now we're speculating.
Oh yes.
But one thing that comes to mind is that one paper that I read noted that there are plenty of mammals that gallop and bound. Mammals that gallop more often tend to have more rigid, shorter bodies. And mammals that bound more often tend to have more flexible spines.
Yep.
And mammals have famously flexible spines. It may be that there's a spinal structure that just isn't conducive in reptiles to a lot of hopping. But also bipedal hopping, as we've seen, tends to start off doing something else.
Yes.
That bounding seems to potentially give rise to bipedal hopping in mammals, and that arboreal habits are what has given rise to bipedal hopping in birds, and lemurs to the extent that they're doing hopping. So if reptiles aren't well suited for those types of... I wonder if it's just that they're not well suited for the precursors to true hopping, outside of specialized lineages like birds.
I would also wonder if there's kind of a flip scenario of, while we see lots of bipedal hopping mammals, we don't see a lot of bipedal running mammals. While with reptiles, bipedal running is much more common. Yeah. And maybe it's like, oh, we don't need to do that. I'll just sprint.
Yeah, and that's the other thing, is if there's no reason to, running is...
perfectly good.
As much as we've talked about the benefits of hopping, even in quadrupedal animals, most of them run at high speeds
Yeah.
and don't hop. Most of them are just galloping.
There's tons of running mammals, but we are one of the few mammals that runs on our just back legs.
Yes. And in fact, we are...
I can't think of another one that actually runs on the back legs.
Yeah, just left, right, asynchronous running. We are exceptionally good at that. Outside of us, that's a thing that reptiles do.
Yes. So like maybe it's just that the fast form of bipedal movement that's good for one group isn't good, or there's already an alternative in the other group.
Yeah. So yeah, for whatever of these reasons, hopping and reptile. Now, all that being said, if tomorrow we discover a kangaroo hopping dinosaur, I will not be the least bit surprised.
No,
sure. It's a therizinosaur that was hopping around.
It's like, surely there was one. You were around for so long and you were so weird and so diverse. Surely one of you decided that you wanted to bounce.
Now, there are two other ones that I want to make mention of because otherwise our entire discussion is limited to the Mesozoic and Cenozoic. I did find two papers that are just fun to mention from the Paleozoic.
Ooh.
One is a 2006 study that is jumping traces from insects from the Permian in New Mexico. This is, again, where, this isn't hopping like we've been talking about in the other animals, but this is a trackway of apterygote insects, which is wingless insect, the basal group of insects. Wingless, which... another thing that I didn't mention before, one of the other reasons why it's hard to characterize hopping capabilities in insects is because so many of them can fly.
Yeah.
It's like, but half the time you hop and just don't come back down.
Yes, exactly.
And you can flutter from place to place. These are wingless insects, similar to modern day like bristletails and silverfish are wingless insects. This is a trackway from New Mexico that shows a linear succession of jumps.
Neat.
That it was a bunch of foot tracks and then jump, 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 which they noted we see that same sort of movement in modern bristletails.
Oh.
That when they need to move fast, they do a rapid succession of jumps.
Cool.
So a hopping sort of motion to move forward.
Neat. Well, it makes me think. What it makes me think of right now is Super Bunny Man. Of like when you're at that size and with the right body shape, you can kind of just keep kicking, and you'll just move forward like little wind up toy insects where it's just gonna go, zzz, but that it eventually gives you forward motion. It doesn't have to be the same synchronized, perfect jumping that we think of with man. If you just keep kicking those legs back. Every time you land on your belly, you'll move forward.
And then there is one more, technically the oldest report I found of a hopping trackway. This is a 2021 study that identified an Ordovician trackway of hopping trilobites.
I was wondering.
Now, technically, swimming.
Yes.
Trilobites are bottom dwellers in oceans, but this is a study that actually did hydrodynamic models of certain trilobites and compared them with some known trackways that might potentially support this. And they put together this concept of trilobites jumping off and then sort of drifting forward in the water for a bit and then landing and kicking off again in sort of an underwater hopping locomotion.
Cool.
This seems to be supported by the models, some potential trackways, and they noted that if this is the case, what they were doing, this may be an intermediate between crawling and swimming.
Yes.
That before trilobites become true swimmers, some of them might have gone through a hopping phase.
Neat.
Not at all like the hopping we've been talking about for the whole rest of the episode, but technically the oldest fossil I could find in a paper that used the word hopping.
Yes.
So I thought that'd be fun to throw out here.
Well, and you mentioned earlier that there's lots of bottom-dwelling sea animals and aquatic animals that have hopping kind of motions.
Oh, sure.
Even like mollusks.
I was going to say, octopuses, you have those videos of them sort of kicking off the sea floor.
And there's mussels and snails that will use their foot to push themselves in a kind of leaping motion when they're trying to get away. It's as fast as they can move. And it's got a very hoppy motion to it. It's as close as they can get to a gallop, but they've only got the one limb, so their limbs moving in synchronization. That's very neat.
So, regardless of your definition, we live in a world full of hoppers, and there have been hopping things at least as far back as the early Mesozoic, and maybe farther back if we're counting our bugs and trilobite friends.
So fun.
This was a super cool topic. This was one of the most scattered topics for an episode that I've ever had to tackle.
Yeah.
Because there isn't just a paper about hopping.
Well,
there are all these different types of movement that I wanted to make sure to get to mention and cover in this discussion.
It's a whole bunch of overlapping Venn diagrams that all overlap with each other.
Mm-hmm.
And so you have these things that kind of sort of have features of a couple of different things, depending on very specific adjustments. How are your feet moving? Well, that's a little bit closer to galloping than this other version.
Yes.
And it's because, like, yeah, there's a lot of ways to get this done. But it's so cool that so many forms of life have found it useful as a way to get around or get away.
So, of course, we only touched upon a handful of different things as well. Like we were hopping around, we only touched down briefly.
That's the erratic movement.
That's
so
that
beneficial.
unpredictable. So, dear listeners, if we didn't mention your favorite hopping creatures, feel free to let us know. Get in the Discord or leave a comment on our social media and all that stuff. But let's leave behind hopping and bring this episode to a close. Before we wrap the whole thing up, there is one last thing to do, and that's our patron question. Every episode, we like to pick questions submitted by our patrons to be answered here on the podcast. One of those cool benefits you get at certain levels for joining our Patreon. Will, what do we got?
We got 2 questions. The first one is from Kylie, who asks, is there any evidence of saltatory locomotion in reptiles?
Great question. Whole episode about it.
Yep.
Yeah, as we discussed, the answer appears to be maybe a little bit unclear.
Yeah. Like there's lizards and stuff that can jump today.
Sure.
But that's not the way they get around.
And it's not saltatory locomotion. They're not using that as their main gait. Certainly not much today, and maybe some trackway evidence in the fossil record, but for the most part, reptiles seem to be hopless.
Yeah.
Like big kangaroos.
That's just one of the many things they have in common.
With kangaroos. with giant Sthenurine kangaroos from the late Cenozoic.
I just want a picture of a lizard and a kangaroo going, we're not so different, you and I.
You gonna hop down over there? No, me neither.
Yeah. We got a lot in common, you know? Our other patron question is from Lydia, who says, while answering another patron question, you mentioned a potential world without legs where tetrapods didn't take over the world. I would love to hear some deeper speculation about what that world might look like and how it might have continued to evolve.
This is a fun spin-off of a locomotion episode.
Yeah.
A world without limbs.
Mm-hmm.
My first thought is that if tetrapods hadn't evolved limbs and moved onto land and sort of taken over, that something else would have evolved limbs.
Yeah, like
Because
arthropods
have limbs. There are a bunch of animals that have evolved limb-like things.
Mm-hmm.
Like caterpillars have those extra limb-like things. Velvet worms.
Yep.
Have their kind of limb-like things.
You also have get into the definition of what do we count as are wings limbs or are those appendages?
Sure.
You know?
But in the spirit of the question,
Yes.
if there weren't legs,
Yeah.
what would the world ended up looking like? I mean, a lot of slithering, I guess.
A lot of yeah, absolutely. I feel like you'd get lots of slithering. I feel like you'd get also more things that which is kind of slithering, but that like slug and snail movement where you just have an adhesive bottom portion that can just grab onto the substrate.
Yeah. Well, and I think that it's worth noting that legless animals exist in a wide variety of terrestrial habits and habitats.
Yep.
Snails are everywhere.
Yeah, they are doing super well.
Snakes are everywhere, and there are snakes that climb and burrow and glide and do all sorts of stuff. So I think you could totally have just a world of snake-like slithering things. I also wonder if you would see more things like we talked about before with springtails.
Mm-hmm.
Specialized adaptations that aren't technically legs, but are useful for jumping around.
Yes.
For escape mechanism or for getting up somewhere
or for
high.
like swimming or something that you end up getting like cilia and like flagellum that let you move, but they're not actually legs.
Yeah. Or could you get snail? I'm imagining sort of the snail roiling underside with hooks on it for climbing and for gripping to surfaces.
Yep, that's what I was thinking of. Like, I could absolutely see there being vertebrate descendants that don't have limbs but end up with this gripping, this muscular foot underside like a snail, but it's just muscles and hooks or rough skin that let them climb trees by just hugging onto it.
Yeah. I think you could have a lot of the niches that you have today without limbs like that. It feels like it would be a very slow-paced terrestrial landscape.
Yeah, I don't think you'd have nearly as high speeds being, and there are there are snakes that are quite fast.
Sure.
And there's the one that can turn itself into a wheel.
Yeah, I was just thinking that we talked about that in the news not too long ago.
So there definitely are fast legless things, but they're still not nearly as fast as something with legs.
Yes. Yeah, the fastest snakes are I could outrun snakes.
Yeah, absolutely.
They're fast, but they're not fast. They're not horse fast.
And so I wonder if things would be slower. I also, in a similar form of less octane, I wouldn't be surprised if you have a lot less flyers.
I was just thinking, because our vertebrate flyers evolved their wings from legs, but insects don't seem to have done that.
Yes, it seems like that came from a different portion of the body.
So technically, in theory, you could still get insect-like wings without legs coming before them.
Yes. And so I could definitely see there being flyers, but I wonder if it would have evolved fewer times, because insects evolved it, but that's the only non-vertebrate to have evolved it that we know of.
That was it for the first 150 million years of life on land.
And then every vertebrate group, it's been arms. So if you don't have arms and legs, it's not impossible. You could do kind of an insect thing and be like, well, I just stretched out part of my skin.
I made it from gills.
My ribs became
something like that.
Wing structures, but it does seem like now you're starting further downhill because you don't have these extensions already.
Yeah. I could see arthropods still pulling it off.
Yes.
I could flying snails.
Yeah. Yeah.
Or something that starts off like a millipede and becomes a short millipede with hooks along the body so that it can grip onto things. If you can get climbers, I feel like you can get flying. Yeah, sort of can come off naturally from that.
And I definitely think we'd have gliders for sure, because gliding can from climbing and everything.
Yeah, the tricky part with that is that every animal that flies in the real world jumps to fly. Yeah. And they jump with their legs. Yeah. Now, as we discussed, there are other ways to jump. But yeah, I wonder if it would have to work a slightly different way. I do think that there would be reason to fly because if everything is limited to crawling around on the ground, plants are just going to grow up. Yes. To get out of the reach of all these things. So I think there would be lots of climbing, and I think that there would be a benefit to being able to go from plant to plant like there is in our world.
Absolutely. No, I think I wouldn't be surprised if what we see is kind of what happened with insects, is a group figures it out and then diversifies like crazy now that it's the only one that can fly. Yeah. And then maybe maintains as basically the only one to ever do it. I wouldn't be, if it's just that it's not as likely to happen with this limbless world. So when it does happen, they just take over and then hold that throne for the foreseeable future.
Yeah. So it sounds like it's a world of snaky things and sluggy things and flying blob arthropods.
Yeah. Oh, it's very, I can't remember what the one cryptid snake, the chubby sausage snake.
The Dunsparce snake.
Yep.
Yeah.
I keep picturing a lot of things like that aren't just all serpentine, but are just this a bunch of limbless herbivores,
just scraping up grass and stuff.
You would even if you're a vertebrate, you don't need to be long and sinuous. You need a big gut to be able to digest that plant. So you're just this little hockey puck of a Roomba animal, and just drum, and your stomach just slowly moves you forward. Probably a lot of armor. Yeah, I bet a lot of armor.
Well, and a lot of burrowing.
Yeah,
I think there'd be a lot of burrowing, a lot of litter dwelling, boring. Into trees and stuff.
So it might be a more defensive world than escape focused and pursuit focused. It's
Yeah.
you need to either hide or defend yourself because neither of you is going to outrun the other particularly well.
Well, there'd be a lot of ambush hunting.
Yeah.
And like, like we talked about in last episode, ballistic tongues and
Yep.
stuff, or traps to try to catch things without having to move very quickly,
Ooh,
especially if there's flyers.
There's a word for this of when you fall from the tree to ambush.
Sure.
But like gravity assisted ambush, where
Yeah.
the fastest I'm going to move is while I'm falling, so I'm just going to hang out on these branches, and when you come underneath, I just fall on you.
Yeah.
Cool.
This is a pretty fun world. One thing
Yeah.
that I would love to add to this world, completely arbitrarily, I think that the mushrooms have legs.
Okay, yeah, yep.
So, hey, listen, if animals aren't going to do it, I think that fungi will have legs.
I just started watching
Goombas.
Delicious in Dungeon, and they have legged fungus, so just like that.
Thank you, Lydia, for that thought-provoking question. Listeners, if you have thoughts about our limbless speculative world, let us know. Leave a comment on the social media. Join us in the Discord. Discord's a great place for conversations like this.
We got a whole speculative section.
There was a whole speculative place on the Discord. Thank you to our patrons for asking questions. Thank you to our patrons for supporting us in the podcast. Be sure to check out the blog on our website. Each episode of the podcast gets a blog post, and that blog post will have extra links for more information and pictures and stuff. Don't forget that this episode has come out in June, which means that it is Croc Month. Officially, all June long, we are celebrating the second best animals in the world as a prelude to next month, where we'll be celebrating the best ones.
Boo.
For Snake Month.
Boo to your announcements.
During Croc Month, we got all sorts of cool stuff going on. We're going to do a Croc Month live stream on World Croc Day. That's the 17th of June. We are going to have themed stuff going on the Discord and in our Patreon stuff. Our Discord Croc Chat channel is open only for this month.
Yes.
And the Crocs and Snakes tier on Patreon is currently available. Subscriptions that we receive at the Crocs and Snakes tier during the summer on our Patreon will contribute to charitable donations we will be making to reptile conservation efforts. And don't forget that this year, thanks to a wonderful listener, donations are being matched. So this is a great time to join and help support us and our fans' favorite reptiles at the same time. Thank you to all of our listeners who requested this episode. Thank you, as always, to our patrons for their support and for submitting questions and for all the ways that they engage with us and help us do what we do. And a special thanks to our top tier patrons, Danielle the Bug Lover, Sarah May, Robert Mart, and Melissa Barksdale. We release episodes every fortnight. The next episode, it's Croc Month.
Yeah.
And this episode was not at all very crocky.
Nope.
But we have a tradition.
I tried to sneak some in as I could, but
Just a little bit. Snakes got mentioned a couple times.
Yeah,
But
that's
that's
next
not a whole much. So maybe something a little more themed and special
maybe,
for the next one.
perhaps.
But for that, you will have to stay tuned. This episode is over. Let's bounce.
Bye.
Thanks for listening to the Common Descent Podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.